Hi, my name's Peter Murray. I'm a principal technical architect at GitHub, and today I'm going to talk to you about how we can create a secure coding environment in GitHub and utilize Copilot to leverage some of the great AI features which GitHub has presented with GitHub Copilot. So starting out with this, we were going to talk about the security and compliance aspects that GitHub provides our developers as a platform. A bit of context with this is that from studies that GitHub and industry partners have performed, the increasing awareness of security in the market is not actually resulting in security threats going down, and they actually continue to rise even though people are more aware of these types of features. With this mode of operation, people want to actually start to shift the security concerns and aspects to the left, and everyone's talking about shifting security left. But here's an interesting graphic which shows why that is the case. If you shift left with your security aspects and catch it earlier in the development lifecycle, it's actually a lot easier and cheaper to actually solve and fix in the development lifecycle compared to a breach that might actually occur in your production-based environment. The solution to shifting security left is one that's a little bit tricky, though, in the sense that security researchers are far outnumbered by developers in the community. There's over 800 more developers, 800 times more developers than there are security. So solutions that aid the security left still need to be useful and supportive in spreading the knowledge of these security researchers into the development community. And that's what we're trying to solve with GitHub's advanced security type products. Oops, wrong arrow. So GitHub builds a number that can be leveraged for us to, as a developer, create a more secure software. That with that, we have Dependabot to automate things like pull requests and vulnerability updates to our source. We have code scanning, which allows us to actually scan our code statically using CodeQL to check for vulnerability, provide suggestions around that, as well as integrate with third-party tools and solutions in that space, as well as also providing things like secret scan, secure tokens that should not be present in your code base, and giving you the ability to remediate and first of all identify and then remediate those detections. We also empower the community to make this security process more collaborative. And with that, GitHub has its own open source advisor. We also have the CodeQL queries, and that are open source, and they're collaborated with security researchers in the industry and continue to evolve. And GitHub gives away all of these advanced security features to the open source community. So if you have a public repository today on github.com, you can leverage all of these features today. Alternatively, as an enterprise, you would have to purchase this as an add-on license through GitHub Advanced Security. But GitHub gives these away to the open source community in their interest in trying to make open source software more secure and more robust for the community as a whole. So speaking about the advisory database, the GitHub Advisory Database is free and open source, and this is where GitHub curates most of the security advisories. We do pull from a couple of external sources with this, but this is maintained by GitHub, and all the security findings here are reviewed by a full-time team that will curate these. But we also keep this as open source, so you, as the community, have the ability to influence and improve and raise pull requests and changes to actually get these security advisories improved if there was a incorrect aspect to them. So it's an open source platform from that perspective. And last year, GitHub curates almost 1/3 of new advisories. That was the findings from last year. So we are the fairly dominant provider of security vulnerabilities advisories today. Leveraging this, we can start to use Dependabot. And Dependabot with the security advisory database allows us to actually identify vulnerabilities in your software. So if you're using an open source package that happens to have a vulnerability in it and can be matched to the security advisory database, then Dependabot can actually then identify and tell you about this. So by using this, it allows you to understand if you have vulnerabilities in your code base, as well as then potentially providing pull requests that will update them and execute your CI/CD automatically for you to validate if those changes are breaking or not. This is fully integrated with the developer workflow and can be enabled with just a few simple toggles within the repository, which we'll get to when we take a look at this in the demo. On the code scanning side, we give you the ability to apply CodeQL queries, a static code analysis tool that will actually analyze all the execution paths in your code base and identify places where you may be vulnerable to certain vulnerabilities. Out of the box, we focus in on very highly confident findings, but you can tweak this and add your own rule sets and expand upon the types of rules that you want to apply to your code base, giving you the flexibility to decide what's important for you to actually look for in your code base and what types of vulnerabilities and patterns you might want to detect. The other thing that you can do with this is you can write your own custom queries, or you can leverage other security researchers' queries. So teams from Uber and Google, for instance, do write their own queries, put them into the open source repositories, and you're able to actually fetch and pull these so you can share with the community as a whole. And then finally, secret scanning allows you to activate this on your code base. And there's two slight variants to this. One is the secret scanning that will automatically go back and look through your entire history of your repository, searching for any known tokens that we partner with. So things like AWS, Azure, Google, all of those types of keys. And our partners continue to expand. They define the secret patterns in that to look for, get added to the scanning that we do. And then if we find those tokens in your code base, we will alert you as to whether or not that secret is present. The other thing that you can do as an enterprise owner is you can start to define your own custom patterns. So you can define things which are secrets to you. So they might be things like credit card numbers or some kind of internal token, which is a secret that shouldn't occur inside your code base. You can define your own custom regex patterns for those, and then apply and detect those within your own code bases as part of GitHub Advanced Security. So that's all very powerful, but we also have the ability to add push protection around this. So there's an option to enable this to actually stop it reaching GitHub and ending up in your code base. So what we have here is a feature that you can turn on a repository that, as a developer, you can still commit locally in your IDE of choice, a secret, but when you go to push that up to github.com, we will scan the code, and if we detect any secrets, we will block that. So that makes it easier for you to not have to go and remediate the secrets after the fact, and you can stop them from actually being truly compromised. And sure, the developer would have to actually modify their commits locally, but ultimately it stops them from actually being a big fiasco where you actually now have to go and ascertain how to remediate and revoke those secrets and respond accordingly. So with those features, how will we integrate these within the SDLC? So here we can see that if we're talking about shifting left and using those features that we've already spoken about, the points that we can integrate with is around the project configuration. So as a company or a developer, you can set up code scanning, you can set up the secret detection, and you can set up vulnerability detection via Dependabot or within your GitHub repository. So activating these features is the first piece. Then as you develop and code and test, those changes in that are going to be analyzed and detected and give you the ability to respond to vulnerabilities or issues that may crop up as part of your development lifecycle. And you can also bind these into your pull requests. So these can become part of your quality gates, and that fits into your code review and commit cycle that you do before you even hit things like CI and CD. With all of this, you can build up appropriate quality gates to make sure that you're compliant within your company's aspects, or even just being a good open source developer in the sense that you're taking security seriously and wanting to have the best experience for your downstream consumers. So the other aspect of how we might actually go about applying this and bringing this into the mix is to potentially utilize CI/CD with GitHub Actions. And Actions is a marketplace of over 17,000 actions provided by the community. And that community is not just the open source community, but big vendors like Microsoft and AWS and Google as well, producing their own actions for you to be able to extend and actually start to build out your own workflows that will allow you to effectively build anything in the way that you need to operate. We support any operating system on cloud or on-prem, so that covers Mac, OS, Windows, and Linux. And we provide the runner that you can either, GitHub will provide you cloud-hosted runners, and with that we have our standard pool as well as larger execution runners, which you can pay a little bit more for and gain more features like memory, CPU, disk, as well as private IP addresses associated with it. Or you can even host on-premise, and you provide the compute, you install the runner, and you get the ability to access those particular resources. So that's what we refer to as like the friction-free sort of service. You get to choose where your actual workflows are going to execute. And then with this, with GitHub Actions, you can build, test, and even deploy your applications, and is somewhat agnostic to whatever language you've written your code in. With what is central to that is the GitHub workflow. You define a workflow as a number of jobs, and within those jobs, you have a number of steps to achieve some outcomes. Each of those jobs will execute on a runner, and by default, without actually using sort of needs type syntax and chaining, all of this will execute in parallel. So it's about being able to execute from start to finish as efficiently and quickly as possible. The workflows themselves are defined in YAML and committed into your code base inside your repository. But within that, it's extremely highly configurable, and you can extend it using things like the bash scripts and the like, or you can even go as far as writing your own actions and extending within that. GitHub has a number of extension features, which I'm not really going to go too deeply into today. But we have reusable workflows, composite actions, where you can define a number of steps which make sense to execute together, and you can share these across your organizations and that internally, defining your own patterns and also use them for compliance. The other thing that GitHub Actions gives you out of the box is like access to the starter workflows. So on your repository, if you want to get started with Actions, starting out from scratch, GitHub has curated a number of workflows that tend to match the types of patterns and operations that we see companies and individuals trying to achieve. So in this particular example, what we're seeing here is a publish a Node.js package. So that was suggested specifically for the repository. So that means there's probably a package.json, and JavaScript is quite possibly the language of use here. The starter workflows interaction and our recommendations for that are always based around what's already been detected inside the repository, surfacing that to the top. But if your workflow isn't already covered there, you can happily browse through the rest of the workflows and get ideas for things like deployment to AWS and Azure and the like. These are kept up to date and continue to expand, and they have a focus on sort of giving you a starter template with a large number of comments that you can tweak to actually achieve what it is that you're trying to build with your workflows. Within the Actions ecosystem, though, every action, so every job and step that executes can generate things like status checks. So these can actually then be utilized within our pull requests system to provide quality and security gates. So by using GitHub Actions, we can implicitly already get access to and define branch protection rules, which will require certain checks in that to be successful before you can say merge that pull request. So this can tie into things like our CodeQL scanning that we might want to do, checking for vulnerabilities and making sure that that passes and gives a green check mark before we're allowed to actually merge that into our main branch, for instance. Right, and now we come on to Copilot. So GitHub's Copilot is an AI Copilot that sits next to you in your IDE, giving you suggestions and helping hand for you to either write code or potentially template things and just assist you in getting stuff done. It gives you the advantage of an AI sitting next to you to increase your productivity. And it does this by giving you suggestions which are relevant to what it is that you're trying to achieve. It can help you to prototype and innovate more rapidly. So you can potentially ask it and guide it to give you a helping hand to get started with frameworks and things that you may not be overly familiar with without having to actually escape the IDE and go and have to read documentation. And it can also aid in bridging those skill gaps where it might be a library or something that you're not actually particularly used to. That's an open source library. And so it can give you good suggestions and patterns that make sense to how that library is used in practice. Copilot is installed into your IDE. We support a number of IDEs, Visual Studio, Visual Studio Code, NeoVim, and JetBrains IDEs. And once that's actually installed into your IDE, Copilot will start to interact with you and give you suggestions based upon the context under what you're doing. So as you type away, a context is generated that is passed up to Copilot, which then is using the OpenAI codex. Some suggestions are rendered. GitHub does some magic within Copilot to filter out things like insecure code and various aspects that you don't want to see based upon your settings for the Copilot activation on your account or organization. And then it will provide you some suggestions back, which you can choose to accept or either as a whole or take parts of it and get further suggestions and clarify the code. From our findings, just some high-level numbers here. Research has indicated 88% of developers have faster completion time on tasks when using Copilot. So it gets a lot of the templating out of the way and helps people develop code faster. 87% exert less mental effort on the repetitive tasks. So, defining your types and templates and, structures of your language that may be just a lot of typing can be helped a lot by Copilot. You spend 77% time less searching out on the internet, so coming out of your IDE, falling out of your flow and having to go and Google something. With that, 73% report that they stay more in the flow when they're working. And then things like 60% are more fulfilled within their job. So, rather than completely, writing template code, you can get more satisfaction out of what it is that you're trying to achieve. So with that, let's jump into a demo of how we might take a set of source code to Git repository, apply some security coding practices with GitHub, and then use Copilot along the way to help us get to where we want to be. So here's an example repository that I have. I know very little about this code. It's been thrown over the fence to me. I'm going to now pick up this code and trying to complete what is outstanding on this particular code base. So with that in mind, we have a README here with a number of completions here that are necessary for us to complete. So I'm going to open up a Codespace. So with GitHub, you can create a Codespace directly on your repository. We can see we've got the dev container definition here. So this is going to give us a customized code space. In the interest of time, I started one up earlier. So here is my code space in the cloud. We can see that it's running. It's got a number of extensions that have been installed, and all of this is controlled via our dev container definition file. So we can see that we're using Docker Compose, forwarding some ports, and we've got some customizations here, which are extensions that we want to see installed inside our IDE. And here we get a consistent coding environment. So as a developer, every developer on my team working on this project can get a consistent, fully set up environment ready to go at the click of a button. With this, we can see that we've already got Copilot installed. So Copilot manifests as a icon on the toolbar, and I've also installed the Copilot Labs, which we'll touch on, which is it's a peek into the future of what Copilot is wanting to achieve, with sort of new functionality and evaluating new aspects. So let's start out with what we need to do here is we need to add a Docker file to our project. We've already got a Docker file, and we can see that there's actually a bit of a comment here as to what the intent was as to what we're trying to achieve. So using this particular intent, we'll be able to actually guide Copilot to actually give us some kinds of suggestions that we're looking for. So by hitting enter here, we can see that Copilot's now come up with a suggestion, and the first suggestion is in fact a comment to create the build container. We've specifically asked it to add a build container on Node.js version 18. So that's what it's actually going to do for us. I accept that, and now it's producing another suggestion here, which is telling me, Node 18 Alpine. It's implicitly grabbing Alpine from the second line, which is telling us we want a production container on Alpine. So it's giving us some kind of consistency here as to what we're trying to achieve. Sure, that looks good. Now we're going to copy our package JSON files across. So this will help us to do the installation of our packages. So we're copying that across. We mentioned that we only want to install our production dependencies. This looks good to me. We're then copying the rest of the files across. Not entirely necessary in this case, but good enough. And then it's going to help us produce our production container. And as we can see here, I'm not typing anything. I'm just accepting each of the outputs that Copilot is suggesting. And there I have a working Copilot, a working Docker file, which is actually doing exactly what I've asked for. It's exposing port 3000. It's running my npm start to actually run the application. It's copying the dependencies from the production container. That's pretty impressive from a workload aspect, in the sense that I didn't have to go out and read the Docker file documentation. I didn't have to go and clarify anything. And in fact, I've now got a functional Docker file. So now we'll commit that. So git start. And then we can start to get this working back on our application. So now we've got a working Docker file. We should see that version. We can see the Docker file has been pushed up to our main branch. So first of all, now let's start turning on some of the security settings that we might be interested in here. So we're going to enable some Dependabot alerts and the security updates on our repository. And then we're also going to enable the GitHub Advanced Security features on our repository here. So I'm underneath an organization, so I have to pay for this. So that's what that prompt was. But now with GitHub Advanced Security here, I want to add some code scanning to our repository. And GitHub offers you this nice feature where you can actually get started with code scanning quickly right here from the setup. So I can select the setup. I'm going to go with the default options for CodeQL analysis. You can see that we have detected that it's JavaScript as the language. I get the ability to either select the default or extended. Default is the recommendation with our highest precision queries, which focus in on very accurate results. Or I could go with things like the extended, which starts looking at lower severity and higher precision queries. In this case, I'm going to choose extended because I want a little bit more coverage. But then I also have the ability to actually select, see the events that this is going to be triggered on. And if I enable CodeQL with this, GitHub's now implicitly just written me a workflow file. We can see that this is going through the setup. But in a moment, we should be able to see that the workflow file has been created, and we should have an actions workflow executing, which is now going to analyze our code base to actually see for CodeQL vulnerabilities. So we'll wait for this to just finish its setup and start to generate some scan results. So we can see that CodeQL is now running on this, and that's going to pump through any of its findings into the security tab, which we'll come back to in a moment. So we've got our Docker file. We've got our code scanning turned on. We're checking for our vulnerabilities at the moment. The other thing that we need to do is actually look to actually build our source code. So we've got this workflow file, which has already been partially created, and we saw that that was erroring on our repository there. And we've got some sort of intent as to what the original developer was actually looking to achieve, which was to trigger on the push event and then run against multiple versions of Node, installing our dependencies and run the test. So I'm going to utilize Copilot here to now help me build my workflow for this. So once again, it's suggesting a name of build based on the context under which I provided it, which is the name of the file. With that on push, so it knows that there's an event. So on any push on any branch, we will get a build of this workflow. And here we can see that it's completely pre-rendered a complete workflow. But it's done some fairly interesting and complex things. So two things have just happened. One, there's this public code match, which we'll touch on in just a moment, but we'll talk about what it's actually suggested here. So implicitly, from just reading all of this, it's decided to target the GitHub Cloud hosted runners with Ubuntu latest. Because I mentioned I wanted to test on both nodes 16 and 18, it's implicitly worked that out to mean that I'm going to want a matrix strategy. So I'm going to want to execute this on multiple versions, and it's actually coded my workflow to accommodate nodes 16 and 18 from the comment that was present in our code. It's then going to check out our code and then set up Node with the specific version that we are targeting in the matrix, run npm CI and npm test. So this is a completely functional workflow, all set up by Copilot as per the requirements. Now, we saw the code quote was triggered on this, and I'm running with Copilot for Business, which is looking at matching against open source contributions. So what will happen here is that this is triggered because over 150 characters in my suggestions here from Copilot has actually matched existing open source code that Copilot feature knows about. And here we can see there's references to those particular files where they exist in the cloud, as well as some details around the licenses associated with it. So here we can see that there's no assertion licenses applied to each of these things, which have matched. Now, the reason it's matched in this case is that it's a workflow file. It's a fairly sort of standard pattern under which I'm trying to achieve. This isn't really code. It's a GitHub workflow, and it's not uncommon to actually get those type of matches in place for that. So now we've got a working workflow file. Let's add that and go back and have a look at what security findings we've got and how we might go about fixing those. So we've pushed those up. We should now see we've now got the CodeQL executing. So CodeQL was previously added, so now it's checking our code for vulnerabilities. And we can now see that this build is now actually executing as a matrix strategy. We can see it's building on Node 10, and we'll wait for it to complete.
Security features that have been activated on our repository.
Actually, that's already been successful. So that's all good. We can click on the security and actually start diving into the details. So two things here that we've got two noticeable vulnerabilities that have been detected. First, we'll take a look at Dependabot. And Dependabot has dependencies as per the dependency graph, and it's actually managed to match a number of these vulnerabilities against the versions which have vulnerabilities, and the one that we're using has these vulnerabilities. We've got a critical vulnerability. We can click on that. It will give us the ability to go and review the security that is actually a fix for this. So we're currently using 151 and 159 will fix this, and itself will be able to actually open the pull request for that for us and execute our CI/CD. And you can always click into that pull request, and we can see here that this pull request was opened. There was CI associated with this, but this is associated with a previous version of this repository. So this should have been opened, but I've reset the repo just before the demo, unfortunately. So that's why that shows is closing. Is closed, but this would actually be open otherwise. So with that, we can gain insight and deal with those types of dependencies. And fix those automatically by just having our CI/CD execute off the back of that, and then we can merge them. And then on the code scanning side of things, this is where we've got CodeQL. We can see that all tools here are working as expected. And what are those tools? Well, we can click on this is an unshipped feature. This is part of something that we're currently working on, but it will give you the ability to dive into the specifics of each of these tools and see what they're actually analyzing within your code base. With CodeQL, we can see that all our code here was actually physically scanned, but we did find a vulnerability in our code base. So if we take a look at what was detected by CodeQL here, is we can see that we've got a database query that is potentially influenced by external sources. So a user of our application can influence what's going to execute on our database here. So if we take a look at the paths, we can actually see all the way through from the source. So here we've got an Express app which is taking a user input for an author, and then all the way through our code base, we can track this down to where we eventually hit a select query on our database where we're not correctly creating that query and allowing and exposing ourselves to that vulnerability. If there were multiple paths, we'd be able to actually see those multiple paths, but in this case, there is only one. And then one of the awesome things about CodeQL is that you can actually treat it more like a learning resource, in the sense that with everything that it finds, it will give you recommendations and examples of what is good and bad practice with these types of findings. And it will always show the examples in the language of your of the detected vulnerability. So if this was Java, you'd have a Java-specific vulnerability. Examples here associated with the vulnerability, as well as any external resources which are associated with this, which you can also use to learn and educate yourself as to how you might be able to defend from these types of practices in the future. Now, with that in mind, I know I've got a vulnerability in my code base, so I can come into my IDE, I can open up the source code for this, and in our in-memory database here, we've got the injection here. So this is our vulnerability, which has been identified for us. But we can, with some interesting new features within Copilot with Copilot Labs, we've got these things called brushes that you can now apply. So I can select that code base and I can click Make Robust. And that did not work well. It is a labs thing, so it will be a little bit variable at times, but this should be able to actually modify. There we go. No, that didn't do anything that time either. But the idea with these types of brushes is that it can analyze your code base and modify the queries. And this was working last night, I can guarantee. Come on, Copilot. There we go. So there we finally have, on the third attempt, has sanitized our data and made it secure. So these brushes and that are part of the Copilot Labs functionality. The Labs extension is only available to Visual Studio for Code at the moment. And it's really a place where you can experiment and test new and fun features that are being experimented with and may eventually make it into the main product. But this is a very powerful way for you to actually potentially write robust code, and using Copilot's AI and the filtering that Copilot applies to the actual physical model. If it was writing this from scratch, here it inherited some code that a human had previously written, it tends to filter out most of these security vulnerabilities before it even makes them to your suggestions. So that's an area that GitHub has been working on in that space. So we could, make that change. We can add that to our code base, and vulnerability. And with that change made and pushed up to our repository, we will now get our workflow to execute, which will validate whether or not that vulnerability is fixed. And if it's fixed, it will close that out implicitly for us. So all without having to, as a developer, to leave my area where I work them. I can get understandings of what I've been vulnerable to. I can make the changes necessary to it. I can push those changes and then ultimately build that back into our workflow here. Now, the one thing that we can do before we sort of conclude with this demo and move over to some questions is the other thing that we can do is add branch protection rules. So here we haven't got any branch protection rules on our repository. So we can do things like require a pull request, require approvals from reviewers, owners, and things like that. But we can also activate the ability for certain status checks to be passing. So I can activate the status checks, require them to be up to date, and search for codes QL here. For example, the analyze step here, which is part of the CodeQL workflow, I can add that, make that a required. So attach that to my main branch, create that as a pull request, as a branch protection, for our pull request. And then any pull requests we would make would have to satisfy those particular checks as we go through making the pull request. I'm just aware of the time. I'm going to conclude there and open it to questions. So working through the Q&As here, the Copilot Lab brushes, so that's part of the Copilot Labs extension. So inside your inside here, if you search for Copilot, there's the GitHub Copilot Labs, which if you install, you'll get access to the brushes. There's also some great features for like writing tests and explaining code and even translating it into other languages. On the copyright issue, the litigation is still with the courts. GitHub and Microsoft have recently asked for a dismissal of the current findings, but it's in the legal process. So it's pretty much just watch that space as to where that's going. As far as Copilot for business, so for companies that want to use Copilot, you will be protected as part of the terms and conditions of using Copilot if you stay compliant with the terms and conditions that GitHub specify. When you adopt Copilot, we will indemnify you on that front. Next question. How do you evaluate which code scanning tools policies are most relevant to you? Turn it on first. So I would start out with the high ones and then start to read the documentation on github.com as to queries and things that you might be interested in adding. You can always turn those on and off and modify the queries that will be applied as part of your developer workflow and configuration files. And that's all documented on github.com. How useful, efficient is GitHub Copilot when maintaining an existing code base? For example, fixing bugs and refactoring code. It's pretty good for writing code. Context is always relevant. So if you have multiple tabs open for your source code, and that it builds context from that. So as you work as a developer and start to code and write things, it's going to sort of get better with its suggestion. So in the case of like the in-memory database here, I'm just modifying the code here. It's actually suggesting to add some kind of functionality here because I hit enter, which is telling me you haven't got a search by book ID. So I can start actually writing code around that, and it will start to give me suggestions about how I might go about implementing that which is consistent with the code that's already present in the file. So from a refactoring perspective, I've written a piece of code which is going to search for a book by ID, for instance. And I think we're at time.
Yeah, Peter, thank you so much for the talk, and also thank you for going through the Q&A.
Greetings from EFICode, the organizer of the DevOps conference.
Developer experience is regaining attention because having satisfied developers lead to better software and ultimately happier customers.
Reach out to us and let's discuss how we can enhance your DevOps practices together.
Visit eficode.com for more information and have a fantastic time with the DevOps conference talks.